Go here, testing. Hear me?
Recording in progress.
We are magicians. Throughout history, we have been doing things that people never thought possible. We make buildings rise and stand proud. We make cars move so people can get from one place to another. And we've made it possible for people to move again when they thought they never could. When the world gets dark, we light things up. And help to make things pure and clean. We help power the world. Give it the fuel it needs. And make sure that we are able to harness and sustain the energy that nature provides. We do things that help make the world a better place. But we wouldn't be able to do what we do if it wasn't for somebody. Somebody who lets us fly, but makes sure we fly to a certain standard. Somebody who keeps an eye on us. And sees to it that we are made of the right stuff. Somebody who keeps us doing things the safe and sustainable way, no matter what. Somebody who makes sure that we are professional in our dealings. Somebody who encourages us to keep learning so we can create more magic. And somebody who tests us so that what we do is always done right. We are an engineering team. We strive to make the world a better and safer place. We are able to do it thanks to the Board of Engineers, Malaysia.
Assalamualaikum warahmatullahi wabarakatuh and a very good morning. Welcome to the webinar of the Engineers in Society EIS lecture series. In support of the Board of Engineers Malaysia Strategic Plan, the Engineering Accreditation Council EAC and the Engineering Technology Accreditation Council ETAC formed the Working Group on National Undergraduate Engineering Talent (NUET). This working group focuses on the development of future-ready undergraduate engineers through a structured program that promote leadership, innovation, ethics, and professional engagement. The working group will spearhead structured initiative to develop leadership competencies, enhance professional exposure, and embed the core values of the engineering profession. Among the initiatives under NUETS are Industry Talk under the Engineers in Society, Industry Advisory Panel IAP Registration Mechanism, and Innovation Competition involving final project and integrated design project. On each of the slides, there is a QR code located at the top left. If you have any question, you may scan the code and submit a question there. Due to time constraint, we may not be able to answer all questions live today, but we will respond to them in due course and upload the answer on the Google site. So let us begin with the Module 1 Engineering Career. This will be presented by Yang Berbahagia First Admiral Dato Engineer Dr. Ahmad Murad Omar. Yang Bahagia First Admiral Dato Engineer Ahmad Murad Omar is a distinguished engineer and retired naval officer with over 33 years of service in the Royal Malaysian Navy. Retiring at the rank of First Admiral, he holds multiple engineering and strategic degrees, including an MSc and honorary PhD. Following his retirement, he has led several engineering and marine consulting companies. He is a fellow of the Institution of Engineers Malaysia and currently serves as council member of the Engineering Accreditation Council (EAC). At the international level, he was honored by the Institution of Marine Engineering, Science and Technology in the United Kingdom as Honorary Vice President for Life, in recognition of the outstanding contribution to the maritime industry, both locally and globally, making him the only Malaysian to have received this prestigious recognition. His extensive leadership and technical expertise continued to inspire and shape the engineering profession in Malaysia. Please welcome Yang Bahagia First Admiral Dato Engineer Dr. Ahmad Murad Omar.
Thank you very much, Engineer Zairul, for magnificent introduction. I hope the line is clear, and it is a brilliant morning today, and I shall try to cover this within the time that is allocated. Thank you. Next, today's outline of my talk will cover the following topics, as you can see on screen: engineering career, engineering discipline, engineering sector pathways, where it will take you, engineering career development, and how are you going to do it. Number three is where you are going to, and number four is how you're going to get it done. And number five is something that is going to be in the future, the likes that you probably would like to take. And finally, how you continue to prop yourself up for the future and meeting the challenges of what is to come in the next century. Next, let's begin with engineering diversity. Engineering offers a myriad roles across the technical and managerial fields. Maybe at the beginning you will begin as an engineer, but somewhere along the line, as you climb up the ladder, you will nevertheless pick up to take up managerial positions. Opportunities span across public, private, and academia. Public, like JKR, Health Ministry; private, like companies like Proton, like Produa, Petronas; and academia is like University Technology Malaysia, Unimas, and so on and so forth, including polytechnics and colleges. Yeah. The career growth depends on your discipline and the sectorial that where you end up in, which we will discuss later. These things, the discipline will not change much, but the sector may, and individual experience in the industry as you pick up along the way. Next. The engineering disciplines, as we know it, the fundamental or the traditional disciplines spans across civil engineering, mechanical engineering, electrical engineering, and chemical engineering. And as stipulated at the bottom of each of the photos, you can see what are the related fields: infrastructure development for civil, mechanical more for manufacturing, and electrical more for power system and electronics and software driving systems, and chemical engineering processes like renewable energy, hydrogen, and so on and so forth, as we can see today where the nation is going. Next. Now let's look at the engineering sector pathways that is available to you. I understand that most of you, if not all of you, are still in the undergraduate stage. We're still learning, probably in the various years of learning and semesters. So this is something for you to ponder on. So these are the likely divisions of sectorial that you may end up after you have graduated. Of course, the first choice up on the line is public sector. Public sector is like joining the government agencies, the local council, JKR, Health Ministry, Ministry of Defense, and that kind of organizations, yeah, and agencies, focusing more on infrastructure and regulatory compliance. Number two would be the private sector. And now this was in the past seems to be the choice of many undergraduates, because this is where the sector that pays a bit more than the public sector, but it is not so now. But then again, things may change. The private sector offers dynamic opportunities, and this is where the dynamism of engineers moving across sectorial and also moving on along with the challenges of the present uh, technological advancements. The next one, the third one would be academia and R&D. Academia is where you are now. Yeah, some of you may come back to the universities to become lecturers, and you probably end up as researchers if you join the research university, like UTM, for example. So this is a choice maybe some of you like to pursue. Next slide. Entrepreneurship. Now, entrepreneurship is something, as I said earlier in my opening, it is a choice that many engineers pick and choose as a result of your career development. Now, once you graduate from the university with your degrees, you will probably pick up a pathway that you think at that time is best for you. But boys and girls, remember this. Yeah? The dynamism of engineering and technology advancement in the world today, as we know it, is far-reaching and far too wide for you to actually to pinpoint on one particular choice. So my advice would be, do not narrow down your choice at the very early stages of your life and career. Yeah, let it sink down and move along. Next slide. Now, as we also alluded earlier, you are all studying in universities. So there'll come a time when you will graduate. Yeah. Now, what you learn in universities would be preparatory in terms of knowledge and skill sets and understanding of engineering to prepare oneself to meet the future of the demands of the engineering um, fraternity. It is a vicious world out there, in the technical world. However, the university will try as its best to actually nurture you and prop you up with the best of information and knowledge, so that you are equipped and be sturdy and knowledgeable in trying to pursue whatever that you wish to pursue in the future. What lies in the future is anybody's guess. So, as an earlier career in your college days today, you probably end up with internship program of 10 weeks where you attend your industrial training, which is not a lot of time. 10 weeks is not a lot of time, but you pick up something along the line there as well. Once you graduate, that's when you start joining industries. Of course, when the point where time when you enter into industry, you will have a lot of anxiety, a lot of concerns, and a lot of fear. But let me remind you, all these things has got to be put aside. Yeah, because the fears will come, anxiety will be there, but it is up to you to actually move along and pave your way across the challenges that are coming online. And the best thing would be to prop yourself up would be to be joining professional societies, professional bodies like IEM, Institute of Marine Engineering Science and Technology, IEEE, IET, as a student member. And this is where you actually begin at a very, very tender young age as a student to actually engage with people who are already in industry. And then, of course, the next one would be the graduate training programs. There are a few at the moment, and where you can actually subscribe to it. Once you graduate, there is this what we call protege program, where industries take young undergraduates under their arm and work with them and pay them a salary or allowance and see how they fare. Take this opportunity for you as a stepping stone. Next slide, please. Now, going on further, once you have got that what we call uh, preparation, yeah? Joining society, getting to know, learning from peers, learning from icons, learning from your tutors and mentors. Yeah? These are people who are around you. They will not identify themselves. It's up to you to actually locate them and target them. And these are the people you should be around with. Yeah, the professionals. So in engineering career development, it begins with number one, the early careers, which I just mentioned earlier. We don't want to repeat that. And number two would be the middle level growth, taking up increased responsibilities and specialization. Now, in the what you call beginning years, in the humble beginnings, if you like, yeah, you will probably be very what I would call in your knowledge level would be from 1 to 10, maybe at maybe 3, because that is all what you picked up along the way at your university degree course. And once you finish that, you are ready to learn new things. Yeah. And then this is where the middle level growth. It will take about 5 years for you to scan around you and pick up along the way and do whatever that I just said earlier, talk to people, be with people, be around people who are professionals. And then as you go along, you come to your maybe 7 or 8 year or maybe 10 years when you are about 35 years old or 40, you are ready to be, you are equipped and propped up, ready to take on the challenges of advanced roles. This is when you become managers. This is a point where time when you become senior managers. Yeah, some of you may, if you are very good and you are very forceful in where you want to target yourself to be, you may be a senior manager after when you're 40. In the oil and gas business, there's a lot of young senior managers. Yeah, some of them are already country managers, like my son-in-law, for example. Yeah, he's only 44, but he is working in Qatar in Doha, and he is in charge of the Schlumberger petroleum. He's a country manager. So basically, at that young and tender age, you can be there if you want to push yourself to be where you want to be. Next slide. However, in the process of engineering career development, the transition to lead team, this is something that is not taught in the university. Yeah. At the university level, you are taught the theories, yeah, and the mechanics of how things move, how things work. But the transition to become leaders is something that you have to pick up after you have worked. And also this depends a lot where you end up, which organization you are in. Some organization take very particular attention to actually nurture their engineers and their senior managers to in the future lead the companies and become the C category officers. Yeah, C category here means the C-suite, yeah, the chief technical officer, chief operating officer, and even in some companies, even the CEO. Of course, that will come with a big reward at the end of the tunnel. Yeah, obtaining professional certification is very important as you go along. Yeah, just to set an example about me, I started off with a humble beginning of a diploma um, person in UTM. When I graduated in 1978, I worked for 1 year, came back into my degree. And after my degree, I graduated in 1982 and I pursued to join the Navy, and that is where I got my training. And in 1999, I did a double master's in the same year and qualified in both masters. One in professional master's in defense and the other one as a engineering professional management, in business management. This is what I equip myself. I picked a master's, not mechanical engineering, but a Masters of Science in Business Engineering Management, where I cover things like financial management, project management, and the development of creativity and innovation. So this is where I said, somewhere along the line, you have to make a choice. The pathway is there for you to grab. But what you choose and what you grab matters to you because it dictates where you will be in the future. And because of that, partly probably I became the chief engineer looking after 35 billion worth of assets in the Navy, running it alone with 5,000 engineers under me. At the age of 47, I became the Director General of Engineering. And then after that, 5 years later, after which I retired. I have served 33 years, and it's time for me to make way for the younger ones to take over. Now, exploring interdisciplinary roles in the current setup of the engineering fields, it is something that you have to make a choice. The flexibility is something, a trait that you all need to work on. Yeah. Flexibility, interdisciplinary, intertwining or between mechanical, civil, electrical, and all that culminate into one melting pot. And today we have heard that some universities like UTP are generating what you call integrated engineering as a degree. They've realized that in the oil and gas industry, you don't need a chemical engineer alone. You don't need a mechanical engineer alone or electrical engineer alone. You need a mixture of all. Next slide, please. Still on the subject of your career development, becoming a technical expert is something every engineer wishes to be. But it is something that may not be achievable by all. However, you will not be able to achieve anything if you have not given it a try. So try you must, young boys and girls, you need to actually strive because I strive even today. I'm at 71 years old. I got my honorary doctorate from University of Malaysia, Terengganu at the age of 67. So if you think 67 is old to study, no, it is not. So engineering consultants offer expert advice to improve project outcome. Now, expert advice can only be given by people who are qualified and who are experienced. And qualification and experience, boys and girls, is not something that you can go to the shop and buy. Can I have a kilo of experience, please? Can I buy 20 kilos of knowledge? You can't, because knowledge you get at the university level, but experience, and improving on your decision making process all comes along the way in your growth and in your pathway as you choose it to be. You need to have a clear vision on what to do and where to get it from. Next slide. Now, once you are already, now we are not talking about the middle growth, but we are not talking about the third level, which is almost the final, not final, but towards the end of your career path development. In one thing about career path development, boys and girls, it never ceases. It never stops. Yeah? Don't ever you think that, oh, I'm done with engineering. No, you're not. You're not going to be done with engineering, because engineering is something that will fix you in the end if you are not dynamic and you not move with time and with the engineering technology advancement, as we can see later in one of the slides I will cover. Yeah. So one of the other ways that I said earlier is for you to join professional bodies. And when you join professional bodies, they always organize talks, technical talks, presentation by iconic leaders. Go and attend this. Listen to them, because you can learn lots and lots of things from this talks, and also try to get involved with the professional bodies, because only when you involve with them you will see the outlook of how things are looked at by different people in different countries and different sectorial of engineering. Yeah. So that is a point that relates to why I was appointed as the Vice President for Life by Institute of Marine Engineering Science and Technology in London. They don't just appoint a Malaysian to be Vice President for, unless that person has shown that they are passionate about the whole engineering, technology, and in the industry. And as you go along, we also need to go hand in hand with ethics. Now, ethics is very fundamental, very important in engineer's life. because ethics is actually the core of your person, the person in you. Yeah, a person who is a qualified engineer without ethics is quite useless. Yeah, in my mind. Yeah, my opinion. So when you join this organization, you can also contribute by giving talks yourself and sharing your experiences. That's what we are doing now today. I'm 71 years old. I got almost 50 years of experience. I'm sharing it with you. Yeah. Those days when I was your age, nobody came and talked to me about this. Yeah. And I'm happy that we are doing this for you, and you should embrace this for your future pathway. Next slide. Still on the subject of lifelong learning, because as I said, life learning in engineering doesn't stop. It's not like 100-meter dash. When you cross the finishing line and say, okay, I'm done in 10 seconds, so I go up the podium and collect my medal. It doesn't work that way. In engineering, it doesn't work that way. It goes way, way, way past that. You go way, way past the finishing line. You probably go another round of 100 meters, another, a different stadium, different people, different country, and different challenges you will meet. Yeah. Now, as we know that in engineering, there is this industry 4.0, which touches on what are the things in the future that one engineer must embrace. Next slide. So the things that you need to embrace, as is in the IR 4.0, there are 11 pillars of that. These things like automotive robotics, yeah, simulation, vertical integration, industrial Internet of Things, cyber security, artificial intelligence, new business models, the cloud, additive manufacturing and disruptive management, and the big data analytics. So these are some of the pillars what the Industrial 4.0 have taught us. And this is something that you cannot dispense with. You cannot just throw this away into the bin. You can't. Because this is what is set out in the future. Today we got the National Energy Transformation Roadmap, which tells you about in 2050, there will be no more fossil fuel in this country, yeah, and also in the globe. So where do we go from there? So we should go and look at renewable energy. We should go into solar energy. We should go into electrical cars and automobiles. But even that probably is only a temporary measure. Once the hydrogen sets in, and you find that the green hydrogen will find its place in the country, in the globe, in the future. Because that will deter the climate change, as what we are experiencing in Kuala Selangor last night and in Kedah, in Songkla, where the floods are the resultant of climate change. So this is where that you need to grow with the not only the dynamics of technology, you need to also grow with the information. So how do we do that? Get yourself a professional accreditation. Yeah. Once you are qualified according to the Act, after 3 years of registration as a graduate engineer, go for your IR examination. Get your IR, get your PH, yeah, and maybe later even get your PEPC, yeah, which then you can sign drawings and submit tenders in the future. But if once you have that, because you are equipping yourself not only in terms of knowledge, but also in ethics and also in competency. Continuing with that, once you got your PE or PEPC, then you will have to make sure your continuous professional development is maintained. Yeah. For PE, you need 25 hours, and for PEPC, you need 50 hours. What this entails is that continuously you learn new things, you attend talks, you deliver conference papers, and if you are in the academia, your research, you actually produce new things in engineering based on new technology and get them commercialized and patented so that we can actually produce them in Malaysia and sell them in the global arena. Next slide. Now, going further, a step further than engineering career development, we are blessed with having the Board of Engineers Malaysia. The Board of Engineers Malaysia, as we know it today, is our mentor on the engineering fraternity, how we perform, how engineers perform. Yeah, and we pack ourselves for the engineering degrees to the Washington Accord. And then for the what we call the technologies, the Sydney Accord. And then for the technicians and the diploma graduates with the Dublin Accord. So we are safe. And once we are aligned to the global standards, you can go anywhere. You can work like my son-in-law. He's working in Doha, in Qatar, been there for the last 4 years. He has been abroad ever since he left the country. And everywhere he goes, he's always going upwards. It's never lateral or it's never going downwards. But what makes him go upwards is not because he is very good at talking. No, he's very good in his technical prowess and his leadership qualities. He can manage clients who speak not the English language and the Bahasa Malaysia. You know, he works with Koreans, he works with French, he works with Italians, he works with Qataris, and the Arabs are quite difficult to work with, by the way. Next slide. So enhancing our global mobility just now, you see that BEM is paving the way. And what you need to do now for your readiness, whether you ask yourself, am I now really ready to become an engineer and meet the challenges of the present and the future? Because you are young, you are only about 20 plus years old. I'm 71. I'm almost riding into the sunset with my horse. But you guys are just beginning. You are the replacement for people like me. Yeah. And many others who are like me. There are plenty of us. So you are like the replacements. You will take our shares, you will take the lead after we have long gone. So you need to know where you are going. You need to know where the direction you want to pick. Because, and how do you know this? Of course, you cannot just lie down and sleep and dream. You will not come through your dreams. You need to work on this. Yeah. You need to find out this. You need to talk to people. You need to do a lot of reading and you need to speak to your icons, your mentors, and your peers. You know, see how things are. You know, when you do your what do you call internship, speak to the companies that you work with, the engineers there, ask them, you know, are you happy here? You know, what else that you need to do, you know, if you want to go further up. So these are things that you pick up along the way, as I said. You know. It's like a rolling stone gather a lot of moss. Yeah? As the saying goes, a rolling stone doesn't gather moss, but you are a rolling engineer and you are picking up a lot of moss along the way. Now, of course, you have to be communication-wise savvy. You have to be savvy in speaking and talking to people because this will enhance your convincing capability and your flow of thoughts. Yeah? And a lot of engineers today are lacking the flow of thoughts. Yeah? They know, they are brilliant, they know the technical bits and pieces, but to express them is another challenge. Of course, the next step for you to do is try not to be too, if you are thinking of setting your pathway now, don't go and start looking at 100 items for you to do. Maybe it's too much. Yeah? Just start with small numbers. Yeah? Maybe 3 or 2. And in the next 6 months, what you plan to do. Okay. Once you graduate, you tell yourself, I will be an IR, I will be a professional engineer within 4 years after I graduate. Now that at least there is a KPI for you. You make your own KPI. Next slide. So your networking very important. You know, who you are with, who you engage with, who you speak to, who you learn from. All these are important, and they're all human beings. They're all people. Of course, you can go to Chat GPT. Today, there is what you call Mr. Chat GPT. Yeah, everything solved by Chat GPT and by this voice and face, cartoon face that you talk to when you want to pay your bills or when you don't pay your bills, they will call you. But the point I want to say here is the human element is still very crucial and very important. Yeah, because the mind of a human does not work like the AI computers. That is something that even the scientists today are baffled. Well, no matter how good is the AI, you still cannot beat the human because it's the human who make the AI. Next slide, please. So, here are 3 things that I hope you take. Okay. First, begin with the end in mind. Okay, like me, I never knew that one day I will hold a PhD honorary. Neither do I know that at the age of 47, I will be responsible for 35 billion worth of assets and people. I never thought of that. When I graduated with my diploma, I thought that's it. I'm going to be just a worker, a mediocre uh, technical assistant, for the whole of my life. No, you shape your life. Okay, if you don't shape your life and you don't push yourself, you are going to be, as I said just now, just a mediocre engineer. And do you want to be that? Do you want to be a mediocre engineer? Yeah, experience is your best teacher. Now, I said earlier, I have about 50 odd years, 40 odd years in my background. Yeah, when I was operating my ship on board, or I was on board a ship operating the machineries. The moment the machinery sound different, I call my machinery control room and I ask my engineers, what's happening to the engine? And they ask me, nothing, sir, nothing wrong with the engine. No, you better go and check. And true enough, when they come back, say, sir, how do you know there's something wrong with the engine? From where you are? I was about 3 decks above where they are. I didn't come down even to the machinery room. So you see, this is the thing when this skill set, yeah, the knowledge I get are not gotten from the shop, not gotten from the universities, but it is gotten through experience. Yeah, experience is your best teacher. Now, last but not least, invest in yourself. Okay, when I did my double master's degree, yeah, of course I had to pay for the second master. The first master is free because the government paid for that. When my training officer in the Ministry of Defense asked me, he said, are you crazy to do two masters in tandem at the same time? I said, no. I said, one, I attend the day classes, that is University Kebangsaan Malaysia. The other one, I attend a master with Warwick University in UK, and that is weekend classes. So you said, you mean Mondays to Friday you go to UKM, and Friday, Saturday, Sunday you go to UK? No, I don't go to UK. UK come to me. And actually, I qualified both masters at the same period. To the surprise of my training officer in Ministry of Defense. So boys and girls, again, invest yourself, push yourself, because this will pay off. Yeah, what it pays off for me is in clear view of my success stories. Thank you, and I think oh yes, that is the last slide. Thank you very much. Okay, over
Thank
to you,
you.
Engineer Zero.
Thank you so much, Yang Bahagia Datuk, for your presentation. We have a few questions from participants. The first one, why did you choose engineering, Datuk? Can you share with us?
Okay, good question. Now I got to go into my time tunnel and go back to during my school days. I wanted to become a doctor. I'm not going to lie to you. I want to become a doctor. But what happened to me during my biology class, the specimen that I was dissecting a frog, after putting it, killing it with from formaldehyde, it came back to life when I was operating on it. So that actually puts me off in biology and my dreams to be a doctor. And my teacher said, I think you forget about being a doctor, you go and do engineering. And that's probably one of the things that triggered me to the. But the more important, the reason why I pick up engineering, because I was in the military college and I'm so flabbergasted by looking at the navy white uniform, so nice, and I said I want to be wearing that uniform and I want to do engineering. And engineering at that time, the Navy offered a very good package. Probably that is also the other reason why I was certainly taken into the pathway of engineering. Yeah, it is partly my choice, but more so because the organization facilitated me. So, like yourself, is the same. Yeah, see how things are for you around you, and hopefully, I answered the question, Engineer.
Thank you so much, Dato. The next question is, as a newly registered graduate engineer, how does BM support young engineers in Malaysia to build professional competency and progress towards becoming a professional engineer?
Okay, to begin with, young engineers are encouraged, as I said earlier, as soon as you can make your KPI, you achieve your accreditation as a professional engineer at early stage of your career. I graduated with my degree in 1982 and I got my IR in 1989, 7 years after. And during those days, it was so difficult to get to pass the exam. But for you guys, BEM today doing outreach program. We go down and meet industries. We encourage industry. I just came back from East Malaysia. We went to see Sabah Electric Board. We went to Sarawak Engineering, Sarawak Energy Berhad. And this is where we went. Sabah Energy Berhad. Actually, 200 of their engineers working for them actually attended our talk. So you see, BM is actually going down to the ground. We are meeting your young engineers. We are answering their questions. A lot of questions asked by them. But today they are so happy. They say, okay, maybe for a start, those people who have registered with 3 years experience, they will do their IR exam, submission in first quarter of 2026. So this is one of the things that we encourage. But for you as a young engineer, I recommend as early as possible, get yourself professionally equipped, by accreditation and by registration. Thank you.
Thank you, Dato. Next question is, beside internship, what other opportunities can help students gain industry exposure?
Very, very good question. Yeah, because internship is only 10 weeks and it's only, I think, 3 credits, if I'm not mistaken. I can be wrong. But in the whole of 4 years engineering studies is only 10 weeks in industry. That's not enough. That's not enough. Okay. Now, what you can do is actually, as I said, you're networking, meeting people, joining professional bodies like IMAC-E, ISTRAC-E, IEEE, IET. These are professional bodies in UK. Yes, they cost money, but for student member, it's free. But for once you have graduated, then you have to pay lah. Yeah, but it's okay. This is what I call just now. Invest in yourself. Pamper yourself, boys and girls. Yeah, because only if you spend this money now, you will get more money in the future, because you are qualified and you are trained and you are experienced. So don't just hope things to roll down your feet. You have to actually grab and run after it. Yeah. So the board of engineers will facilitate and continue to be seen to facilitate young engineers by the outreach program, and also our the new 5-year strategic plan is also already incorporating this direction to actually nurture more engineers to get themselves registered. At the moment, we are only about 200,000 odd registered person in the country, and we need to actually fill up the target ratio of one engineer to less than 100 population. We at the moment we are at one engineer for every 130, and we have to improve on that. Like Germany and Japan, they are at one engineer for about maybe 50 or 60 population. So if you want to be a negara membangun, an advanced country, nation, that is where we should go. Thank you.
All right, next question, Dato. What common early career mistakes should young engineers avoid?
Okay, you very, very sorry, pardon me. That's a very, very tricky question. Okay? But my answer is quite simple. You will not know that you have made a mistake until you make them. Right? Okay, it's a dichotomy. So basically, what I'm saying here is in your humble beginnings as a young engineer, you are expected to make mistakes. I remember the day I reported duty as a fresh graduate after I finished my degree. My immediate boss told me, Murad, welcome to this outfit. This is a very important outfit. We make sure the ship all sail and ready to go to war. I said, yes, sir. Very good. Okay. Right? I allow you to make any mistake you want in the next 14 days. And after that, if you make any mistake, I'll come to you like a ton of bricks. So you see that, as I said, this is anxiety and fear earlier. Remember I said, look, put this aside. It doesn't matter. It is not a threat. It is not at all. It is actually a motivation. Yeah. So as a leader later also, you must allow your subordinates to actually make small mistakes here and there, because through mistakes they learn. Because through mistakes they gain experience. And as I alluded earlier in one of the slides, experience is your greatest teacher. Yeah. What you learn in university is, yes, you learn all the foundation engineering technical stuff. Good. But what else that you need to go and pick in your what you call purchase cart, like you go to a grocery, you need to push the cart. Yeah. And you buy a Shopee also, you need to have a cart. You put everything in the cart. And those things that you put in the cart are not available in the university when you study. So this is only available after. So my recommendation or my opinion here is, yes, you should be allowed to make small mistakes here and there, because from there you learn. Yeah. But try not to make too many of them. Thank you.
Thank you so much, Dato. And last question is, what advice would you give students about shaping their long-term career, Dato?
Okay. If you have listened to my talks over the 24 slides or so, I alluded to the point that you cannot eyeball or crystal ball your future. No one can do that. I can't do that. But it happened to me. After working as an engineer in the Navy, Royal Malaysian Navy, looking after ships and people and technology advancement, I made the apex, the highest apex an engineer can in the Navy. That is the Director General of Engineering, the highest position ever. And I made it there at the age of 47. Now, in those days, that it was the people that made up that position, their age, either they are 52 or 56. And I made it there at 47. Now, how did I do it? Okay. How I did it is, my advice to you is, along the way, set your pathway right, yeah, and gain and be around positive thinking people. Yeah, this is very important because this talks about leadership. I didn't touch much about leadership because there's one fundamental thing you must remember: if you want to excel in the future in the engineering world, polish your engineering skill, enthusiasm, your ethics, your EI, your whatever that helps you to actually move your people and your organization. Yeah. You will make the C position, the COO, the CTO position, or even the CEO level, in good time and at a young tender age. Only if you have yourself equipped with all that is necessary to push you to that level. I hope I answered that. Thank you.
Thank you so much, Dato, for your answer and very insightful presentation. Uh, we move on to the next module, Practice of Engineering in Malaysia. This will be presented by Yang Bahagia Dato Profesor Engineer Dr. Muhammad Rafiq Abdul Kadir. Yang Bahagia Dato Profesor Engineer Dr. Muhammad Rafiq Abdul Kadir is highly respected engineering leader, academic and researcher. He previously served as a founding dean of the Faculty of Engineering at University Technology Malaysia and currently serves as council member of the Engineering Accreditation Council EAC. A distinguished scholar in biomedical engineering, he has led numerous impactful research projects, secured major competitive grants and hold multiple patents. His contribution extend across academic leadership, innovation, and the advancement of engineering education in Malaysia. He is widely regarded as one of the nation's most influential figures in shaping the future of the engineering profession. Please welcome Yang Bahagia Professor Engineer Dr. Muhammad Rafiq.
Bismillahirrahmanirrahim. Wassalatu wassalamu ala Rasulillah. Assalamualaikum and a very good morning to all of you, future engineers. First of all, I would like to say thank you to the Board of Engineers for giving me the opportunity to talk to our future engineers, and thank you to all of you for joining my talk. Okay, my presentation is a continuation from Datuk Murad. So the presentation outline is as follows. I will talk about engineering practice in Malaysia and the Registration of Engineers Act 1967, the regulatory structure overview, and then the last three, you can see there the registration of engineers, its processes, as well as engineers' responsibilities. Next slide, please. Right, let's start with engineering practice in Malaysia, and I want to start with that phrase, that sentence. It says, engineering practice involves applying scientific principles to, number one, design, number two, develop, and number three, innovate solutions that meet societal needs and enhance quality of life. Now, if you joined this webinar at the very beginning, there was a montage, and in that montage, there was a quote from Elon Musk. It says something along the lines that engineering is the closest thing to magic. Engineering is the closest thing to magic. Then I couldn't agree more with this statement, because engineers don't just work in developed countries. Engineers are the one who create and develop countries. So if you see any countries around the world that are underdeveloped, then you need engineers to develop those countries. Yeah. If we consider Malaysia as a developing countries, then we need engineers in our country, in Malaysia, to make Malaysia and turn Malaysia into a developed, fully developed countries. And if Malaysia is a fully developed countries, we still need engineers more than ever to go far and beyond. Yeah, so it is very important. And congratulations to all of you for choosing engineering to study in institution of higher learning. Okay, so that's design, develop, and innovate solutions. A very important statement. And then it also says about Registration of Engineers Act 1967, Act 138, which is the primary legislation governing the engineering profession in Malaysia. It was enacted to regulate the registration and practice of engineers and establish the board, the BEM, as the statutory body responsible for implementing and enforcing this act. Next slide. Right, let's look into some bits and pieces in the act itself. I mean, you can go through the act, the whole document yourself, but I just want to highlight a few things in this act, in this document. Section 7 and Section 10 mainly. Yeah, Section 7 and Section 10 mainly. So in Section 7, particularly, it defines who is legally allowed to practice engineering and use the title engineer. Yeah. So this act basically shows that nobody can actually say that they are engineers unless they have fulfilled certain criteria set in this document. Yeah. In Section 7, particularly, it defines who is the one who can declare himself or herself as an engineer and can use the title engineer. That is in Section 7. And then in Section 10 specifies the criteria and process for graduate engineer registration with the board. It is a must. It is compulsory for all of you once you graduate to register with the Board of Engineers Malaysia as a graduate engineer. Yeah, and then in Section 10(1)(b) requires engineers to gain relevant practical experience before qualifying as a professional engineer, as a PE. Section 10(2) mandates the passing of the professional assessment examination. So you have to go through an examination to be upgraded from graduate engineer to a professional engineer. Section 10(d) establishes the need for a practicing certificate to provide consultancy services as a PE. So if you want to practice and if you want to become a consultant, then you need to register with the board as a PEPC, professional engineer with practicing certificate. And in this document also you have enforcement and penalties, which details the legal consequences, including fines or imprisonment for unauthorized or unethical engineering practice. Next slide. Right, this is the regulatory structure overview. So you can see there are two items there, basically one in the left and then another set on your right. So on the left, only one, which is the BEM, which is the only statutory body in Malaysia looking after engineers. And then on your right, you can see that there are a few. Yeah, these are just a few of the societies or professional bodies that provide support for development for engineers. And some of them are there: IMM, MySet, IEM, IMAC-E, IET, and so on. Let's move on to the next slide. And these are some of the description of the professional bodies available in Malaysia. Board of Engineers Malaysia is, of course, again, the statutory body, regulatory body for engineers under the Registration of Engineers Act 1967. And then you have IEM, the Institution of Engineers Malaysia, which is a voluntary professional body supporting the development and recognition of engineers. You also have in Malaysia MySET, which is the Malaysian Society for Engineering and Technology, which is a multidisciplinary engineering society promoting professionalism, education, and public interest in engineering and technology. We also have IMM, the Institute of Materials Malaysia, which is a professional society and certification body that promotes honorable practice, professional ethics, and encourages education and skills in material science, technology, and engineering. And then you have overseas professional bodies like the IMEC-E, IET, IEE. These are the institutions of professional bodies registered in the UK. We also have its a Malaysian chapter. So the IMEC-E, a Malaysia branch, which is a UK-based professional body for mechanical engineers. We also have ICE, Institution of Civil Engineers. Again, this is a UK-based professional body. And then you have IEE, Electrical Electronics Engineering. We also have IET, the Institution of Engineering and Technology, Malaysia Network, which is also a UK-based professional body for electrical, electronics, information technology, and so on. And there is one more, which is a Chartered Institution of Building Services Engineers, CIBSE, Malaysia chapter, which represents building services engineers in HVAC, electrical, lighting, and related discipline. Next slide. Right, engineering registration and practice in Malaysia. You can see that there are 5 floors there, 5 floors. So you will start with the first floor. The first floor, floor number 1, which is a graduate engineer. So you are now enrolled in an engineering degree program in an institution of higher learning. So your first job now is to graduate, to graduate. And once you graduate, you must register with the board as a graduate engineer. And you must, in order to get that graduate engineer status from the board, you must graduate from an accredited engineering degree program. So that's number 1. That's floor number 1. And then once you have that graduate engineer, you will start your practical training, and you will only start, all the practical training will only be allowed to be calculated for a professional status after you registered as a graduate engineer. So that practical training for 3 years will be floor number 2. And then once you have achieved the practical training, the 3-year practical training, you can move on to the next ladder, to the next floor, which is floor number 3, which is to take professional assessment examination. And you need to pass this examination, this PAE examination, in order to get to the 4th floor, which is a PE status. Once you pass the professional assessment examination, then you can register with the board as a professional engineer with the title IR in front of your name. That is professional engineer. And then the final step, the highest one, is floor number 5, which is the PEPC. Once you achieved a certain year of experience as a professional engineer, and you want to practice as a consultant, as a consulting engineer, then you need to take another examination for a PEPC, which is the professional engineer with practicing certificate. So these are the levels that you need to go through after you graduate as a graduate engineer. Next. Okay, this slide talks about the 3 categories of engineers. There are 3 categories of engineers. You are not an engineer yet. You are currently an engineering student, and you need to graduate. Once you graduate from an accredited engineering degree program, then you can register as a graduate engineer. So that is the first category, graduate engineer. So you will be recognized as a graduate engineer to practice your engineering skills, engineering knowledge. And then the second category is the professional engineer. And for the professional engineer status, again, you need to take examination, the PAE examination. And after you pass that examination, then only you can put your title IR in front of your name, not as a graduate engineer. Yeah, IR is only for a professional engineer. And then if you want to practice your engineering skills, you want to become a consultant, a consulting engineer, then you must register with the board as a PEPC. Yeah. And in order to get that PEPC, you must pass the professional competency examination, the PCE. Yeah. PAE for PE, PCE for PEPC. Okay. And fulfill all requirements set by the board. And only as a PEPC that you are legally authorized to submit, certify, and carry out professional engineering services for designated works in Malaysia. Next slide. Okay, the remaining slides will be the registration process. You know, how do you register? First of all is to register as a graduate engineer. And you must actually, yeah. According to the Act, you must, as a fresh graduate, in order to practice as an engineer, then you must register with the board as a graduate engineer. And you can register online via MyBM portal, so everything is easy these days compared to the old days that I'm used to. All you need to do is just provide your degree scroll, your IC, passport size copy, photo, and a 50 ringgit registration fee, and that's it. Yeah, and then of course the board will look at your application, and if you graduated with an accredited engineering degree, then you will be registered as a graduate engineer. Next. This one is a graduate assessment program. Now, here's the thing. We have institution of higher learning that offer accredited engineering degree program. However, there are other institutions that offer a non-accredited program. Yeah, something like any local MQA accredited 3-year BEng. Yeah? Or by the Engineering Council, UK EC, yeah? United Kingdom Engineering Council, 3-year. So these are not accredited. But can you still enroll? You can enroll, register as a graduate engineer once you attend this program, which is the BEM Graduate Assessment Program. Okay. If you want to continue and further your study via a master's degree, we will no longer accept those. We will only accept our BEM Graduate Assessment Program if you want to register with the board from an unaccredited engineering degree program. Okay, so this is a must. We have already endorsed this with effect on 1st January 2023. Okay, next slide. Okay, engineering technologists can also register with the board if you graduated with an accredited engineering degree under the Sydney Accord and fulfills all the criteria under Section 10C1. You can register online via MyBEM. All you need to do is to provide your copy of academic qualification, the engineering technology degree, yeah, and again your IC, passport, and payment as prescribed. And you can later apply for a graduate engineer. So once you graduated as an engineering technologist, there is a route for you to get your graduate engineer status. Yeah? You need to fulfill the academic qualification under Section 10(1) of the Act. Next slide. Right. Conversion engineering technologies to graduate engineer. So you can actually, if you want to convert from an engineering technologies program to a graduate engineer, you need a further learning for registered in order to be registered as a graduate engineer, but you must follow the BEM graduate assessment program starting from January 2023. Only our BEM graduate assessment program can be used for conversion of engineering technologies to graduate engineer. Yeah, so there is a route, and the route is for you to take this additional program, the BM Graduate Assessment Program, to convert your ET to GE. Next. Right, so this is PE. So you can either graduate from an accredited engineering degree program or an engineering technologies program. Both can or have the route to become a professional engineer. Yeah, so it's either a graduate engineer or from ET to graduate engineer. Once you have the graduate engineer status, you can register as a professional engineer, provided that you fulfill all the required training as prescribed in the Act. Okay, and the training is a 3-year training, accumulate a minimum 3 years of relevant experience, including design and site work. Civil engineers need 12 months each, and supervised by a registered PE in the same discipline. So if you want to register with a PE in chemical engineering, for example, then you need to be supervised by a professional engineer in chemical engineering, and so on. Okay, and once you prepare, you can submit the application form together with your training and experience report, competency report based on 5 areas: technical, practical, management, communication, and ethics. So these are the 5 areas that you need to show your competency from, in order for you to be eligible to be upgraded to professional engineers. And then once you submit all the application forms and the report, then you can sit for the PAE, the Professional Assessment Examination, which includes a 15-minute project presentation plus an interview. And you need to pass the written examination on Code of Professional Conduct. And upon passing, you can use the suffix IR. Yeah, you can use the title IR in front of your name. Next slide. Okay, this is the last one, the highest tier, which is the PEPC. Who should register? You must be a professional engineer in order to submit your application to become a PEPC. Yeah, and if you decide that you want to open up a consulting firm to become a consulting engineer, then you can only do that with a PEPC status. The professional engineer will not allow you to become a consulting engineer. So if you decide to become a consulting engineer, then you must apply for a PEPC. Yeah? You must sit and pass the PCE examination, the professional competency examination, and then only you can practice as a consulting engineer. And the rights and responsibility of a PEPC is that they can operate an engineering consultancy, submit certified plans and calculations, and legally accountable for public safety compliance, meaning that if there is something wrong, people can sue you. Yeah. Okay. Last slide. Let's go for the last slide. And these are the last slide, the engineer's responsibilities. There are 2 slides to this, and that's the end of my talk. And let's go through the keywords there. The keywords are number 1, uphold public safety. Number 2, maintain professional competence. Number 3, adhere to ethical standards. Next slide. Number 4, comply with laws and regulations. And this number 5 is actually a repeat. And then you have supervise and mentor. So it is actually an acronym SPELS, SPELS. SPELS. Yeah, you must remember this. Engineer's responsibility. S stands for safety. P stands for professionalism. E stands for ethics. L stands for laws and regulations. And the final S is supervise and mentor. Yeah, so these are your responsibilities. Please remember this: SPELS, spells safety, professionalism, ethics, law and regulation, supervise and mentor. Yeah, and you need that even before you graduate as an engineering student, to be aware of these responsibilities of engineers. So thank you very much, Engineer Zairul.
Thank you, Dr. Rafiq, for your presentation. The first question is, how can students prepare themselves for the working world while studying?
Excellent question. So the only thing for you to do now as a student is to join any working groups. You know, you need to work in groups. Engineers never work alone. So you work in a team. Yeah. So find your friends. Join any societies. You know, there are societies within campus. There are societies outside campus. You must join them. You know, that is how you prepare for the real life engineering work. Next question.
Once the title IR has been obtained, are there any specific requirement to ensure that it remains valid?
It remains valid. You need to pay the annual fee to the board. Yeah, so there is an annual fee to the board. That's number one. You need to fulfill the practice. So in order for you to be continued as an IR, there is a form online where you need to fulfill what are the engineering practice that you have done throughout the year. Yeah, so there are certain items that you need to go through, and you need to fulfill certain criterias like man hours. You know, how many hours have you spent in certain engineering practices? Yeah, that one you need to log in to the online BEM online, my BEM online, log in and then key in all the hours that you have spent in engineering practice. There are certain categories. Then you can fill it in, and then you need to fulfill a certain amount of KPI. Yeah. So there are certain points, CPD points, continuing professional development points, and that points are obtained by you joining, practicing your engineering skills. Yeah, for that year. And then once you achieve that CPD points, you can pay to the board in order to continue your IR status. Next question.
All right, thank you. What does the journey from student to professional engineer for you look like? Can you share that?
Yeah, sure. My journey, my own journey would be that I graduated with an engineering degree, and then I joined the industry for a few years, and then after I joined the industry, and it was if I remember correctly, it was a metal stamping company. That's the company that I joined here in southern part of Malaysia, and then I joined the academia, UTM, University Technology Malaysia, as a tutor, and then pursue my PhD overseas, and then come back practice as an academician in a university, and then apply for a PE, and that's my own experience. So I'm still working as a lecturer in an institution of higher learning. Thank you for the question. Next.
Thank you, Dato. And last question is, what guidance can you give graduate who are unsure whether to pursue PE or PEPC?
Oh, that's actually very easy. You should aim for PEPC. Even, well, if you ask me, you should aim for a PEPC even if you don't want to practice as a consulting engineer. Yeah, because in order to get a PEPC, you need to sit for an exam, professional competency examination, and that examination is actually valuable for you. Yeah, don't just aim for PE, for professional engineer. I mean, it is difficult already to get a PE, and to get through the PAE, the professional assessment examination. It is difficult already, but don't just stop there. So my advice to all of you is that go for PEPC. You know, get that round certificate, the round stamp. You know, if it is a PE, it is a triangle stamp. If it is a PEPC, professional engineer with practicing certificate, then it is a round stamp where you can sign any design, any drawing. You know, it is a good experience for you. So go for PEPC, even though you don't want to become a consulting engineer. Thank you, Zairul.
Thank you so much, Yang Bahagia Dr. Rafiq. We're going to move on to the next module, module number 3, Engineering Ethics. This will be presented by Yang Bahagia Dato' Engineer Dr. Goh Tek Cheong. Yang Bahagia Dato' Engineer Dr. Goh Tek Cheong is a civil engineer with over 30 years of experience in engineering, geotechnical consultancy, and project management. He holds a Bachelor in Engineering from the University of Malaya and PhD from the National University of Singapore. He currently serves as Executive Director of MEI Group. He is actively involved with the Board of Engineers Malaysia and Engineering Accreditation. He is presently a council member of the Engineering Accreditation Council EAC. Please welcome Yang Bahagia Datuk Engineer Dr. Goh Teck Cheong.
Thank you. Thank you, our moderator, which is Engineer Zairo. And thanks to BN for inviting me to speak to the future engineers. So today's topic, I'm going to talk about ethics. And as Datuk Murad just now mentioned, ethics is the core. And it is very important that we engineers we are ethical, and we are professional, we do the right things, right? And we engineers, my presentation outline will be as listed below here, which is ethics, professional, ethical example, conducts, consequences, nilais, and also some case study. Now, actually, this presentation slides here is prepared by a team, a committee, and would like to thank them. And what I'll do is I will not go into reading line by line, but instead I will try to share my experience in the slides here. And also, just to inform you, I am from the construction sector. I'm a consultant, and we have civil, mechanical, electrical architects, and I do a lot of factory projects. So I will input here more of my experience in this field. So what are engineering ethics? Ethics are, as you can see here, you have to do the right thing, it's about moral conduct, do the right thing and not the wrong thing, yeah? And professionalism is more of the way forward and about procedures and standards. Next, please. So, as I mentioned, professionalism is about these standards and procedures. So when we are doing all these projects, you see the engineers are handling a lot of multi-million-dollar projects, and some including billions. To share with you some of the projects that I'm handling, and all those are factory projects. Some of them are 100 over million ringgit investment. And currently there are big projects like the semiconductor factories, investors from overseas, data centers, a lot of data centers in Johor Bahru. They are talking about billions. And I know of projects which is 20 over billion ringgit. Just imagine, so huge. And we as engineers, we are involved in these projects. And if we are not ethical, there are a lot of money which is in the wrong hands, So we have to be ethical. So next, please. Now, talking about ethics and professionalism for students, this is for graduates. Students who is going to graduate. So in the IHL level, Institution of Higher Learning, there are a few levels here. And first one, academic integrity. So we expect students not to copy. You do your assignments, lab reports in the right manner. So this is number one. Number two, when we do any publications, engineers academicians do a lot of publications. So it is professional to do the citation. Where do you get this source from? And it is we need to acknowledge these sources, right? Then in group collaboration, we are expected, engineers, you cannot work alone. You need a team of people that we are going to work with, and we need to be a team player, and we have to demonstrate leadership, For example, there are projects in your final year projects, which is integrated design projects. And this is a requirement of EAC standard, where students need to work together. This is to allow our students to practice teamwork and leadership, right? Then in our design, number 4, in our design, in our we need to look into safety, because in future, when we graduate, when we work as an engineer, and we are responsible, and we register with the board, and board requires us, public safety is most important. So we have to look into that. And number 5, professional participation, like Dr. Muhammad Rafri have mentioned. There are so many organizations, and it is important and it is beneficial to be involved in these organizations, this network, because as a personal experience, when I joined IEM and BEM activities, really we learn a lot of things. And also from there, we network with our senior, our very senior experienced engineers, and they will guide us. And of course, community engagement, we have to do some things for the community. And number 7, ethical reflection. And number 8 is continuous learning. We must keep on learning. We must read. We must attend to talks. A lot of talks organized by all these societies. So we should continue learning. Next, please. So this is a ethical example here, where you can see that there's a chemical plant, discharging some toxic waste, dangerous chemicals. And you can see plant, if let's say the plant engineer is aware of this issue, but he's not doing anything, he did not change the disposable method. And other companies doing the same thing because of cost reasons. So this is the wrong thing, and this will actually have safety hazards for the future. Maybe not our generation, but future generation. So what do we do? Right? So as an engineer, when you see things like this, I think we need to at least inform the authorities. So the authorities are the one who is able to handle this case. Right? Next. This is another one where let's say you are doing manufacturing and there are certain faulty machineries. It still can work, but it is faulty. And this issue here, your superior may view it as a not very important, not significant to make any improvement, but you know that this thing may causes safety to the operators, or possible the products that you produce may have certain defects. So those would be different. Some defects in future you will know, but those regarding safety to the operators, I think this again we have to address it, and we have to inform to the supervisor. But supervisor in this case is not. Then I think you as a engineer, you have to state your stance. Possible you may have to voice it up to a higher authority. Of course, this how you act depends on case to case. Next, please. So next is a Registration of Engineers Act. Now, when we graduate and when we practice, we are actually governed. We have to follow the Act, which is the Registration of Engineers Act. And Dato Muhammad Rafiq has mentioned in detail about this compliance to this act, which is a must because they are the one who govern us. So in this act here, you can get this act from the website, and the details are all stated there. So here, what I want to say is, as an engineer, graduate engineer, or not, although you are still a student, you need to read this act and understand, you know. And in the universities, IHL, we also encourage in the program, in the course, to have introduction of this registration of Engineers Act so that the students are aware of this. Next. Now, in Malaysia, we have a lot of acts, and some of it is relevant to our practices. For example, I'm in the construction industry. I'm the consultant. I design buildings. So Uniform Building Bylaw is, we have to follow it strictly. Another one is Street Drainage and Building Act. And there are also others. If you are in the manufacturing, you have to look into Factories and Machinery Act, Hazardous Substance Act. So there are so many acts, and you have to see what is relevant to you, and we have to follow. If you do not follow this act in future, if let's say there's any mishap or any unsafety incidents that happen, then you are liable and you may have to face all these possible legal proceedings, right? Next. So in the registration of Engineers Act, and also in the Registrar Engineers Regulation, Part 4, there is a Part 1, 2, 3, 4, 5, and so forth. What we put on the slides here is only Part 4, which is the Code of Conduct. And in the Code of Conduct, there are various regulations stated here. I do not want to read into detail, but just to highlight. So, like for example, 23, conduct of registered person. How are you supposed to conduct yourself? Number 24, employers, clients, and professions. How you are supposed to every stakeholder, what they are supposed to do, and how do you discharge? Number 25, how you discharge your duties? Number 26, reputation extra of a registered person not to be injured. So all this again, next slide also shows you. Next slide, please. 27. Canvassing and advertising prohibition. So what you can do, what you cannot do, you can advertise, but you have certain things permitted, not permitted by the board. You shall not advertise, sorry, professional service, but you have to follow strictly what is stated in the regulation, right? Next. So Regulation 31, this one is talking about engineering consultancy practice and also registered engineer. You cannot take over others people's job, supplanting, prohibition. So in this case here, let's say, for example, there is a project and there is already a consultant acting for the project. So you being another consultant, you cannot submit drawings on that particular project. So it is your duty as a consultant to go and check whether there is an existing consultant, and if the existing consultant you cannot take over as it is like this. There are certain ways if you want to take over. The first engineer have to give you permission by a release letter. Of course, there are certain other procedures, and the purpose is the board is wants to protect not only the public but also the engineers. So this is stated in the regulation, and also there are circulars talking about second engineer taking over the duty of the first engineer. So we have also regulation 32, the restriction being director, members or shareholders. I do not want to go into detail because you being a student level, you may not exposed to this at this moment, but when in future when you graduate, then you pay more attention. So regulation 33, disclose of interest. Next. And we have also in the circular, the code of conducts of registered person, what you can do, what you cannot do, you know, and the registered person here means the categories listed there. They are also, for example, accredited checker for structural, accredited checker for geotechnical. So this is all stated in the circular. Next. Now, as a registered person, if you go to the circular number 1 in year 2016, you cannot falsify qualifications. And there are cases in my experience where this thing does happen. And when we saw this kind of things, then we will penalize the person who is doing that, right? So then the benefits of the on the right side, the benefits of registered person not to accept benefits of more than one parties. So this is how the board would want to regulate the conduct of the registered person. You are, as a consultant, you already take professional fee from the client. You do not take again from other parties, for example, the contractors or the subcontractors or the suppliers. No, you don't do that. So you just take from your client. Yeah. So restriction of engineers certified work. So each and every party here listed here, they can do certain things, and you can see that PEPC, they can have the control over the design and also the supervision, and this will be actually assisted by graduate engineer, engineering technologies, and also inspector of works. Next. So consequences of neglect. Now, if you do not do the right thing, then you may face consequences. Of course, the duties you, as an engineer, you need to do things safe. We have to, like always the board's requirement, public safety is number 1, you know. We need to design safely. We must anticipate potential failure. And also, we look into sustainable practice. Of course, negligence is like error, failure to follow standards. Standards ask you to put in, for example, a building, a sprinkler system, but you did not put in. You know? So, but in Malaysia so far, the authorities and the consultants and the contractors, we really follow what the standard. So it's very good, right? But I've experienced working in other countries, other not so developed countries. And when I design some sprinkler system, they may ask me to take it out, you know, things like that. So this is definitely a no-no in Malaysia. So I think so we are fortunate. Our regulation and our authorities, consultants and contractors, we really do proper things. Of course, there are some who does not, then in such cases, you may causes loss of life and property. That is very, very sad. And the engineers who does it, they are liable for these legal liabilities, and also you may face legal repercussion. So these are the neglects. Next, please. So now we come to some case studies here, and this case study is regarding the first one is about I think so most of us know it. In some times back, there is incidents where the Highland Tower, the tower number 1 collapsed. And this particular case here, I was when this thing happened, I was working as a young engineer, and I was involved in not doing the project, but I was involved in rescue work, partly where I was monitoring the tower 2. And if the tower 2 next to the collapsed tower 1 is tower 2, then when the tower 2, I was doing the survey using the theodolite. If the tower is moving, I have to raise a red flag and tell everybody to evacuate, things like that. So anyway, tower 2 is okay. So this after the thing happened, there's a study, and we see that I mean there's of course some legal cases, and it's found that engineers approve residential development on unstable terrain, insufficient drainage. So each and every parties involved have some implications, which is listed there, So these are the things that we hope it does not happen, but it does happen. Like for example, the recent case of in Hong Kong, where everybody can see it from the news that so many scaffoldings with bamboo scaffoldings and with some plastic materials. So there's a fire hazard. Next, please. Next. This is a case, I think so, in Hong Kong also, where a consulting firm, they are actually they lost almost 200 million of ringgit, not ringgit, Hong Kong dollar, because of scam. So these are all unethical things that the professionals are doing, So we would like to avoid and be careful that this thing does not happen again. I have still 10 minutes where maybe I would like to share my experience where some unethical incidents that happen where I'm the consultant, and there's a project where the contractor do the piling, and my design 36 meters, and the pile depth by the contractor, they pile it only 24 meters. And at that time, there were more than 10 piling machines. We are able to inspect a few piling machines, but some other piling machines, we noticed how can one piling machine pile in 30 over points per day? Becomes very suspicious. So we investigate. Of course, the contractor say no, and we conducted tests. We conducted dynamic load tests, and from the dynamic load test, we can tell whether the pile penetration depth. And when the reports comes in, reports say everything okay, but I know how to read the signals, and I said, well, tell the tester company, your report is now viewed by someone who knows how to interpret. And from there on, everything surfaced. They said that it's only piled 24 meter. So we blacklist the contractor. Of course, the contractor has to rectify all this work by bringing the machine in the building. Luckily, it's a warehouse, high ceiling, to pile back all the additional piles and additional length. And we blacklist this contractor for 20 over years. So this is something which is unethical. Yeah. So I think I shall stop here. Thank you very much for your patience listening to me.
Thank you so much, Dato' Go, for your presentation, also sharing your experience. We have a few questions. The first question is, how can engineers promote fairness and prevent discrimination in the workplace?
Okay. In order to be, I shall answer this in my experience and also in my work procedure. Now, I'm a consultant. There's a lot of contractors bidding for my jobs. Everyone want to approach me as a consultant, trying to get a job. I have to be fair. I have to treat all the bidders fairly. Whatever information I have, I will share to the bidders. Whatever questions they ask, I also have to share to all the bidders, right? And the client representatives are also involved. So all the assessment, all these are also done very fairly, professionally, so that when the contractor, if they win the job, they know they win through their merits. If they fail to get the job, they also understand that a fair evaluation has been done, a fair decision has been made. So we as a engineer, we have to act that way. Thank you.
Why is ethics and honesty is so important in engineering?
Yes, a very good question. As Dato' Murad said just now, ethics is the core. I totally agree with that. And to us here, engineers, we are actually having a lot of, Malaysia is very fortunate. We have a lot of investors from overseas right now. And all these overseas investors, they are from Germany, China, and America. They are looking at ethics. In fact, when we do a job, we sign an agreement with them. We have to be ethical and so forth. And if we are not ethical, and these foreign investors comes in, they know that we are not ethical. In future, we will affect Malaysia. So far, we are doing well. We are not 100%, but we are doing well. Investors are coming in. That is talking about company and country. But for individual, we need to be ethical. If you are not ethical, for example, say a case that you are corrupted. You are corrupted, you take certain bribery of a project. And people will know. People will brand you as this engineer, this engineer is unethical. And it will carry through your whole life. So I think very important, when you graduate as a young engineer, please be ethical and do not have a black mark on you. Thank you.
All right, thank you. That's the last question. What should a young engineer do when facing an ethical problem at work, such as being asked to approve something unsafe?
I have an incident here where there's a developer. I'm being a consultant. They asked me, okay, I'm going to give you this project as a consultant for mechanical, but there are certain fire systems we would want you to omit, although it's an authority's requirement. So I told them politely, no, we cannot do that. we will be responsible as a consultant. Therefore, I'm busy. I would like to not to participate in your project. So if things like that happen, you better turn down politely, and let them go and continue whatever they want to do. Thank you.
Thank you so much, Datuk Go, for your presentation, also sharing your experience. We're going to move on to the next module, last module for today, Engineers and the World. This will be presented by Engineer Megat Johari Megat Muhammad Noor. Yang Bahagia Engineer Megat Johari Megat Muhammad Noor is a distinguished figure in Malaysia's engineering committee. He currently serves as president of the Malaysian Society of Engineering and Technology, MySET, a board member of the Board of Engineers Malaysia, and the deputy chair of the Engineering Technology Accreditation Council, ETAC. He is also a former chair of the Engineering Accreditation Council, EAC, under BEM. He played a pivotal role in securing Malaysia full signatory status under Washington Accord, Sydney and Dublin Accords, strengthening the international recognition of Malaysia's engineering qualification. An accomplished academic, he has published more than 300 papers in the fields of environmental engineering and engineering education. At international level, he made history as the first Malaysian appointed as chair of Dublin Accord under the International Engineering Alliance, IEA, marking a significant milestone for the nation in global engineering education leadership. Please welcome Prof.
Thank you, Engineer Zairo. Okay, the topic that I'll be covering is on engineers and the world. That means to say we are operating in the world rather than just in the local area. The presentation of my outlines, as you can see, there are about 7 of them, but generally it is all about the roles and responsibilities, about the knowledge profiles that engineers need to actually integrate when solving problems, and some aspects of the impacts related to whatever solutions that engineers do provide. And finally, but not least, is the laws that are required when it comes to implementing all our engineering solutions. Next. So as introduction, the focus will be, since this is about engineers and the world, which is actually related to your program outcome number 6 in the EAC standards or even ETAC standards, whereby engineers and the world are considered as important, and it will actually govern all aspects of whether you design it or you implement the engineering works and so on. You'll have to take into consideration these aspects. Next. Right, these are the 3 standards, and you find that the first one is all about for those taking Bachelors of Engineering, second one, Bachelors of Engineering Technology, and the third one is at the diploma level, whether engineering or engineering technology. And as you can see, this PO6, program outcome number 6, stress clearly about the need for engineers to think about sustainable development approach. Consider them as you are solving problems, including even at the diploma level, but more at the level of considering the sustainable development in any of the solutions provided as well. Although your analysis as well as evaluation has to be done at the bachelor's level. Next. Now, the role. When it comes to sustainable development, we are very much affected in terms of whatever technologies that we're trying to advance to bring in. It has to be a sustainable technology, and whether we do come out with resources, it must be something that is optimized. But all these are meant for sustainable development. What it means at the end of the day is that whatever the environment that we are operating now, our future generation should be able to actually experience or benefit from the same environment that we are benefiting. That's what we're trying to say about being sustainable. That means the development that happens is not going to ruin the environment that we are living in. That means to say it stays as what we are right now, but not degrading the environment as we go along in developing it. Next. Now, in order to do this, you find that the aspects of knowledge required is more of multidisciplinary. It is not just purely technical engineering knowledge. For example, what's written there as WK1 is actually trying to focus on the need to understand natural sciences as well as awareness of the social sciences. Because when we solve problems, we need to make sure that we do have a strong foundation on the sciences, as well as we are going to work with the society, with the environment. Then therefore, social science aspects becomes an integral part of the knowledge required. We'll see that later. And then about the WK5 is actually looking at the various tools that we can use to ensure that our solutions are actually optimized and looking at trying to conserve the resources and so on. That's why we look at whole cost life, reuse of resources, net zero carbon, and many other concepts that needs to be sort of used. And then last but not least is about the responsibility, and especially responsibility to the sustainable development as well as safety aspects. That's what engineers need to do. So when we talk about sustainable, means to say here, we need to consider all aspects when it comes to all aspects of the knowledge related to sustainable development. Next. These are just an examples. For example, when we look at the natural sciences as well as the social sciences, one good example is the environmental science. That means background in your natural science on environmental sciences means you are able to minimize environmental impact. That means to say, if we understand the ecosystem well, whatever we want to put into the system, where we do proper treatment and so on, it will minimize the environmental impact. Similarly with the geology and climate science. In fact, climate science is really important, especially we know, in fact, currently we are facing with flooding and all those things. It's all because of the climate change. So whether our designs are really climate resistant or resilient, one would say. As far as social science is concerned, we talk about people, we talk about environment, talk about society really, and whether our designs are actually acceptable. They will be using our design and so on, right? And whether it is really helping the society or rather it becomes just a white elephant. Next. Now, among the important aspects that we look at in terms of trying to conserve the resources that we use, we have to think about life cycle assessment. That means to say, when we design a particular project or we design any particular products, we have to think about from cradle to grave. That means the whole life cycle. What's going to happen at the end? How long is the life and what's going to happen at the end of the life? Is it going to cause environmental pollution or is going to impact the society and so on, right? So those are the things that we need to look at when we look at the life cycle assessment. When we design for environment. Are we trying to ensure that the ecosystem is not going to be impacted adversely when we design things, right? And waste minimization is just another aspect to make sure that we don't design or we don't do things where we produce a lot more waste. And these waste, in fact, can be quite detrimental. In some cases, it can be prolonged adverse effect on the health of the societies. The energy efficiency is another, as we know that all life on Earth requires energy, and making sure that sometimes we may think that about green energy and so on, but we may be actually using something that is actually burning the carbon source that we do have. So how do we look at making sure that our energy use is actually something that can be recoverable, but at the same time efficient, as we need that in our life. And last but not least is about conservation of water. As we know, water could be the future where wars will be fought, and water conservation is important as in the Sustainable Development Goals. Providing clean water is one of the sustainable goals, number 6, where engineers will be very much involved in, especially civil engineers. Next. Now, professional responsibility with regard to safety and ethics. We've heard about ethics just now, but if we think about the importance of public safety here, whatever we do, remember, we are governed by a set of ethics. We are governed by rules and procedures, right? So when we design things, we are actually trying to do the right thing. And in this particular case, if we talk about sustainable development, we are trying to promote sustainability here. At the same time, we have to ensure that whatever we promote is also safe. And we would need to act with full integrity and making sure that we are actually leading, stewarding the whole process, not the followers, right? That's why we have to push the agenda, be the steward in terms of respecting the environment and making sure that we engage with the stakeholders so that the solutions that we provide will be applicable and acceptable and will be used and accessed by all. Next. Now, the impact. What happens to our solution? Whatever we do will have an impact. Sometimes engineers are seen as transferring problems, right? For example, you do have coastal erosion, you put on this coastal protection, and erosion happens somewhere else. That means it is being transferred. So it is more like transferring the problem elsewhere when we are solving a particular problem. Now, we have to think about this. I mean, it is not just about the boundary that we're working at, it can be beyond the boundary. So the ecosystem itself is important, just like haze. Right? Haze has no border. It goes to any country, even though we may be producing it or the other countries are producing it, right? So it is beyond the boundary, as we know. So the effect on ecosystem, compliance to the law, and making sure that we abide, and making sure that safety is taken into consideration, and making sure that the environment is actually protected in the long term. But most of the time, we tend to focus more on the financial benefits, right? So we have to move along to incorporate other aspects, not just the financial benefits. And I think one of the things that we tend to also forget is about the culture. That means what impact is it going to be on the culture of the nation or the community and so on? So these are things to be considered, not just focusing on technical issues. As far as the societal impact is concerned, we have to understand that is this whereby sometimes when we do solve problems, is it meant to be fully economic gain, or is it actually trying to solve public access, or is it, if we do certain things, is it going to have an impact on the economy of a community in terms of accessibility to such infrastructure? All these are societal impacts that needs to be taken into consideration. That's why engaging with all the relevant stakeholders, especially the community, becomes important. We are not working in silos here. Next. Just an example of the economic impact analysis on our engineering solutions. If we do an infrastructure projects, of course, it will benefit in terms of economic growth and so on, but with it's going to have an impact as well on the supply chain. Right, means to say there will be huge impact on the changes to the supply chain. But if you are actually trying to do something that is about market innovation, you know that these are just innovation that can improve the life of people and also environment itself, but it will not actually have much impact on the supply chain. So anything that you do will have, or maybe not significant to some of the things that is actually part and parcel of the integral component of an economic growth. So here, we must always think about cost and benefit. But remember, as I said just now, cost and benefit, and that benefit is not just a matter of benefit to the company, but rather to the environment, to the society, and the country at large. And that's the sort of benefit that we are looking at. Some may be very intangible. Engineering sustainability. So one of the concept is about resource depletion. We try to preserve as much as possible the resources that we have, especially the depleting ones, and making sure that whatever actions that we do is not going to pollute or making it serious. Because, for example, waters will have its capacity to actually treat itself, and when you go on beyond that capacity, it's going to be dead river or dead seas. Climate change is definitely something that we'll have to look seriously, and maybe even thinking about designing something not for a long period where we cannot do or we cannot adapt the usage of this infrastructure. Because with the climate change, you know that things can change quite rapidly. So design thoughts have got to be taken into consideration, the climate change. But ecosystem impact definitely is something that is the end game if we think about it, right? You have to make sure that whatever design that you do, if you talk about sustainable development, just as I mentioned, the concept of sustainability just now, the future is not going to be much different than what we are experiencing at the moment as far as the environment is concerned. Ecosystem impact is really very, very important. Next. Now, engineering, when we consider safety in engineering, what's important here, I mean, health and safety, right? We need to do a proper risk assessment. Even risk assessment with regard to the climate itself. What's going to happen with the climate having the impact on whatever solutions we are providing? So risk assessment on that has got to be done at the beginning, not later. And then the economics of it, the occupational health and safety of our design, whether is it going to have an impact on the public health, where these pollutions can definitely cause diseases to spread and so on. And the other thing is about the safety standard compliance to them. So these are the important aspects that needs to be considered when you are solving engineering problems, right? Next. The legal and ethical, of course, a lot has been said about the ethical aspects of it. And what you see here, intellectual properties has got to be protected. I mean, we know many time that people will take it so lightly about intellectual property, right? They just copy and, and reproduce without getting permission and so on. And regulatory compliance is something that engineers will have to abide by. Otherwise, there will be a lot of liabilities in the future. Similarly, with the contract, that what you promise, you have to deliver. But liability is something that I think every engineers will need to take seriously about it, because if you don't do your risk assessment on these liabilities possible, you will probably end up in jail or even be fined or removed from your that means registration, the licensing part of it, and many others. So liability is something serious that you need to look at when you wanted to move into this engineering sector. Next. All right. Having said all those, we tend to be very much reactive in the early days. But what is required now is for us to be more proactive, looking at resource conservation, looking at all the tools that would enable us to make sure that the environment is well protected, but at the same time, the social livelihood, the economy is actually healthy and so on, right? So rather than in the past, it tends to be like end of pipe kind of treatment when it comes to wastewater treatment, or trying to solve the problems later. But at the beginning, we may be just looking at it rather shallowly. That means to say, we need to actually consider all those aspects that would conserve the environment or conserve the resources more at the beginning rather than later. Next. There are laws that we have to abide by being engineers. See, these are some of the laws that are listed. And I'm sure that some of them you may have come across it during your classes. For example, like the Environmental Quality Act, those of you who are in the environment or in water or wastewater treatment and so on. But then there are also contract, if you are in doing your, let's say, project management and so on, right? So these are something that you need to actually beef up, understand, because when you are working, all these could be a liability for you if you don't follow them. Next. Here is the specific one to the local authorities. Then there are a number of requirements, for example, like in building control, land use, or even environmental protection, as well as infrastructure development. There are various rules and regulations that you have to follow, whether you like it or not. Although some of these possibly may require sort of updating, especially with the climate change and so on. So, for example, we have to think about resilient building, but sometimes resilient building may not be a reliable building. For example, we design something that is going to be maybe flood prone, but then that building probably could not be operated during flooding, even though it is intact. So what do you think about all these things? That means to say, yes, there are standards, but think about engineers. As engineers, we should go beyond standards as well. When I say beyond standard, doesn't mean that you don't follow standards, but you should think beyond it, right? How to make sure that it is reliable as well, not just thinking about resilience. The other thing is, finally, we are coming to the conclusion of it. Think about eco-efficient innovation in your work. Think about research. I mean, areas that you like to push where resources are actually being managed or conserved. And at the same time, remember, you have the responsibility to steer it, and you have the responsibility to make sure that professionally it is done according to the rules and regulation and with ethical judgment. And last but not least, in order to do all these things, you need that multidisciplinary knowledge where it will actually incorporate not just your technical prowess in terms of knowledge, but you also need your natural sciences, you also need your social sciences, you also need other skills, right? Even interaction, communication, and so on. So that is a good blend of this multidisciplinary knowledge that would actually ensure that you'll be a successful engineer in your endeavors. Thank you very much. Back to you, Engineer Zaro.
Thank you so much, Pramaga. We're going to go straight to the Q&A. The first question is, with a background in structural engineering and finite element analysis, how can one contribute to Malaysia's progress towards the UN SDG, specifically in sustainable cities and resilient infrastructure?
Okay, that's a good question. You've related structures to somebody from the background structures to sustainable cities. Now, think about when we design, we design to make sure that the building will not collapse. We talk about the codes having the factor of safety and so on. But have we ever thought that when we design certain things, with the climate change, is there going to be an impact on whatever we design? For example, if you design for earthquake resistance, right? Yeah, the building may not collapse, but can it be used after the earthquake? Is it repairable? So that will be the elements that you have to think about. If you think about, yeah, it is safe, people can run away during earthquake, it's not going to collapse, but then the building, what happens to it after that? Repairable? So these are the things that you will have to consider. And there are many other examples that you can actually look at as far as looking at structural engineering in relation to the sustainable cities or sustainable infrastructure. Thank you.
All right, next question, Pramaga. How has globalization changed engineering and responsibility standard across nation?
Really, globalization, actually engineering everywhere is the same. The only difference is probably look at laws and different laws. Some are more stringent than the other. So if you are actually working outside Malaysia or be working in other countries, you have to understand the law of the country, right? As far as code of professional conduct, they're all about the same. So making sure that whatever you do, it is within the boundaries of what is allowable. So engineering doesn't have a boundary really, right? But the rules and regulation in some of these countries may differ. Some may have a higher standard, some may have a slightly lower standard. But keep in mind, we're talking about sustainable development, even though there may be lower standards, but you shouldn't be pushing for that lower standard in the first place. Thank you.
All right, thank you, Prof. Next question, how can students integrate sustainability into their design projects?
Very good question. Sometimes I've been asked, well, when I look at some of the universities' work, we were asking about these projects that they were doing. They tend to look at YouTubes and all those and able to solve the problems, right? But the issue is we need to ask the question, what are the considerations that has been made in relation to sustainable development? Say, for example, have you considered about energy efficiency, for example? Have you considered about the whole life cycle of the product that you are designing or you are going to solve? These are questions, right? That's why the tools that are available is already there. But the question is, are we using them? Are we questioning our design? Are we questioning how do we approach our design from the beginning? I think these are the things. Without having that knowledge on all these tools, it may also be difficult when we approach things. Then we only look at cost benefit. That's about it. Thank you.
All right, thank you, Prof. This is a general question, Prof. The first question is, I have about GE registration. Can technology course register with BM with additional master's degree in engineering and experience of teaching in engineering course for about 20 years?
Okay, this is very specific, although generic. You're talking about can a graduate engineer in engineering technology. Am I correct in saying that? A graduate engineer in engineering technology, or is it a graduate engineer?
Graduate engineer. So basically, I think this person he did a technology courses, registered with the BM, engineering technology, but he did a master degree in engineering, and he has experience of teaching in engineering courses about 20 years. I think this is related to the BM gap, perhaps.
Yeah. As far as so when we started registering engineering technologies, we actually registered those before MQA during the MEQA period, as well as before. We do register them if they come from the background of engineering technology as engineering technologists. Now, once they actually register as an engineering technologist, we allow them to actually take a master's program to proceed to be registered as a graduate engineer. Now, if you qualified under that provision to become a graduate engineer, the next step is from the day you become a graduate engineer, you need to have 3 years work experience. Now, if you're from an academic line, the expectation is of that 3 years working experience after registration as a GE, you will have to have at least 1 year work experience at the industry. Now, that work experience has got to be related to, of course, engineering. And engineering and engineering technology, there are overlappings as well. So you do find that some of the work that you may have done as engineering technologists could actually be used. But always remember that the experience is counted from the day you are registered as a graduate engineer. So that's important for everybody, right? Your experience is only counted from the day you become a graduate engineer at the Board of Engineers Malaysia. That's why it is important to get registered immediately upon graduation, whether you want to be an engineer or not, because at some point of time, you may want to, and your experience may not have been counted if you delay your registration. So to answer it in short, yes, you can be a GE, which I presume you're already a GE, right? If you're not a GE, let's say you are still an ET, there is a pathway as well whereby you do a BEM GAP, Graduate Assessment Program, and then you can be registered as a GE, and then your work experience will be counted. So, but whatever happens before that will not be counted.
Thank you so much, Promagat, and thank you, Promagat, for the comprehensive and informative session. We are now at the end of our session. We have a few more questions. There's a few questions. There's one question in particular that one of the participants asked last week. I'm going to direct this question to Datuk Murad. The question that the participant asked, Datuk, is how much salary for a fresh graduate will consider as a success?
Okay. When the question says how much salary would be considered a success for that particular graduate, would that be looking at the first what do you call the initial salary and not whilst they're already working?
I think it's the first salary.
Okay, the first salary would be simpler to answer then. Because in our study that we did, we are looking at a salary scale of between 3,500 to maybe 4. Yeah. But in the marketplace today, the initial salary offered by SMEs and also by industries somewhat varied and myriad. It's not consistently fixed to one. But if we are looking at the government, it is quite simplistic. Yeah, government scale would be more easier to manage. But SMEs, it range because you join Petronas on the first year, you probably be drawing something like 4,000 plus. If you join semiconductor industry in Penang, probably get about 3,800. But if you join an SME workshop somewhere in Puchong, you probably get only about 2,500 to 2,800. So my answer is that there is no fixed package for initial salary for engineers. But if you ask me what would be a successful or acceptable salary, initial salary for engineers, fresh graduate, I would say between 3,000 to maybe 4. It is on a wide range lah, yeah, because it varies. I hope that answers the question.
Thank you so much, Dato. Right, next question is to any of the speakers. What initiatives does BM offer to help engineering graduate transition smoothly into professional practice?
That's a very good question, actually, because we only require graduate engineers so far to be registered with the board as a graduate engineer. And then you have to chart your own way on how to become a professional engineer. But of late, what the board has done is trying to look at, in fact, this coming strategic plan is going to focus on it a lot in terms of developing talents at the graduate levels, whereby we'll be looking at how can we develop fresh engineers, right, towards becoming professional engineers. That's coming. But in the meantime, we would expect that graduates would continue to get mentoring, especially from professional engineers as they are working, so that they can be guided as to towards their career to become professional engineers or professional engineers with practicing certificate. But then there are other professional societies that are available that you can actually work with, be part of it, where they would actually provide you with the assistance in terms of the courses or even advice, and through the involvement that you actually participate with. So I think that's what I can say for the time being. Thank you.
Thank you, Pramagat. Right, next question. This is probably for Dato' Go. Most of the client, they will go for cost saving. Nowadays, construction cost is going higher. How can we advise the client beyond the design?
Yeah, cost is important criteria, and a lot of times when we design things, where the cost is not on the table yet, the client will say they want everything good. They want Mercedes, but when after that when we do the cost estimate, oh, it's too expensive. If this is the price, we cannot move on with the project. We have to do something. And what we do is actually value engineering. Value engineering means that we still achieve the goals of what our client wants, but we look into cost saving. For example, reducing the floor area, using different materials, using local materials instead of imported materials. This is also to help our economy and things like that, you know. So there are various methods of value engineering. So I would say we have to look into value engineering in terms of cost.
Thank you so much, Dato. So this is the last question for each of the speaker. The question is, can you share some of the best resources or events or any program that you attended in the past that helped you progressing your career, and your last word to the participant, especially the students? We'll start with Dato Murad.
Okay. Well, what we have gone through the 4 sessions this morning are very informative, and if undergraduate would really analyze the content of this, the answers are all found in the four sessions. But in a nutshell, my recommendation would be try to set your mind or KPI from the beginning, but do not narrow yourself too tightly at the beginning. Because why? You must also allow some kind of flexibility in where you think you want to go. The pathway is very immense and very large, and what brings you in the future, nobody can tell, because with the technology advancement today. So my advice would be, let it flow. At the same time, try to focus on what are the best skills that you need to put in your push cart, that will make you sail into the 7 seas with a lot of ease and success. Thank you.
Thank you, Dato Murad. Dato Go.
Yeah, my advice is actually there are a few things I also see that talking about PEPC, how to be PEPC. I think one advice, if let's say we are going for PEPC, there is a competency examination. Please do not, for the students, please, and also postgraduate, please do not specialize too soon. Because in the PC examination, let's say, for example, you are applying for civil. In civil, there's a element of geotechnical, structural, hydraulics. So you will be tested all these things. And if you say that you just want to do structural, I think you will fail the exam. So do not specialize too soon if you are going for PC. And also stay ethical. Reputation is important. And we want Malaysia to do well. We want to attract a lot of investors coming in, and we are in the right path. And for individuals, make your parents proud of you. Like I can see Dato Murad is very proud of his son. So this is very important. This is a satisfaction if you are children of important to make your parents proud, your family proud, and also make your country proud of you. Thank you very much.
Thank you, sir. Thank you so much, Dato Go. And Pramagat?
Yeah, I would always say you have to aspire towards being what you want to be, right? As an engineer, that will be the first important thing. Secondly is when you are at the university, make sure that you are highly engaged, get involved with the various societies. It is not just about the classes, but it is also about the university experience. And then after that, if you have that as aspiration, For example, in my case, I remember during my days, I was offered many jobs. That was in those days, right? But the first question I always ask, can I become a professional engineer? Right? And if they say it's not possible by working there, then I had to reject. Those were my conditions then. So you have to really aspire that whether you want to be one or not. And then only you will work your way up. And the other thing that I would say, when opportunity knocks, you shouldn't actually shy away from it. So here, if you really want to be successful, you may have to take chances, go into beyond the boundaries that you are comfortable with, right? That will be the challenges that you will have to face. And usually, the higher the challenges, the higher the risk, but the benefit or the rewards will be much higher. Thank you.
Thank you so much, Promagat. Ladies and gentlemen, across the 4 modules, you are introduced a holistic view of the engineering and engineering technologies profession. Module 1 highlights the diversity of engineering careers and the importance of continuous learning. Module 2 explain how engineering practice is governed in Malaysia and why professional recognition matters. Module 3 reinforces the role of ethics, integrity, and responsibility in every engineering decision. And Module 4 broadens the perspective by showing how engineering solutions influence society, the environment, and the world at large. Together, these 4 modules offer a complete understanding of what it means to be an engineer, balancing technical skill with professional responsibility, ethical conduct, and global awareness. We hope this helps you appreciate the purpose of each module and gain maximum benefit from this lecture series. Thank you very much for the speakers, Datuk Murad, Datuk Go, and Promagat. And thanks again to all participants for attending this webinar. And please don't forget to scan the QR code and to download your e-certificate. On behalf of the Board of Engineers Malaysia, we would like to wish all of you the very best in your studies. And once you have completed your program, please do not forget to register with the BEM. We also wish you the very best in contributing to the engineering profession and the developments of our country. Thank you very much.
Thank you. Assalamualaikum.
Thank you. Assalamualaikum.